Here we go. We are doing 2016 Calculus AB, number 2. This is AB only. So for this particular year, you won't have to do integration in regards to the velocity and acceleration, but you still have the concepts of velocity and acceleration and the derivative involved. So we're going to do this one, and we'll skip the parts. Well, I'm going to do the parts, but I already told you to skip parts C and D, but I'm going to do all of them, possibly for future years of this. So let's do it. So we're starting at 0 and moving to positive values of t. We have the velocity is given by this function. I'm going to punch that into my calculator. I should have done it ahead of time, but I forgot. Shouldn't take very long. And remember to get that fraction there, the t squared over 2, you do alpha y equals and select number 1. And then we have t squared, so x squared over 2. So I have that entered. Part A, one more thing. When x is 0 and t equals 4, another way to write that, x at 4 equals 2. So part A is a particle speeding up or slowing down. So that is one of your justifications, and that's based upon the velocity and acceleration. So if the velocity and acceleration have the same sign, the speed is increasing. If they have opposite signs, the speed is decreasing. So we need to find the velocity at 4, and we need to find the acceleration at 4. But the acceleration at 4 is the derivative of the velocity at 4. So that's all calculator work. So to get v of 4, I'm just going to do alpha trace, get my y1, parenthesis 4, and I get 2.978. I just truncated. Then I do math 8 to get the derivative with respect to x. Again, I select y1, and I plug in 4. And I have the acceleration as negative 1.164. So velocity, the object's moving to the right. The acceleration's negative, so it's accelerating to the left. Well, if it's moving right and accelerating left, that means the speed of the particle must be decreasing. So I would conclude the speed of the particle is decreasing. Why? Because v of 4 and a of 4 have opposite signs. Done. Part A is done. Part B. Find all times t in an interval where the particle changes directions. Well, to change directions, your velocity has to get to 0. And your velocity would have to change signs at the point at 0. So I'm going to say v of t is 0. And where is it equal to 0? Well, I need to do that next. So on my calculator, I'm going to find where v of t equals 0. So my windows, I'm going to go from 0 to 3. My x min is 0. My x max is 3. And I want to know, well, the maximum of this function is 3. So just to make it symmetrical, my y min, I'm going to make minus 3. My y max, I'm going to make 3. If you graph this, I see the functions going up, right there. So it crosses the x-axis somewhere between 2 and 3. So I do second trace, I select 2, which is find the 0. It asks me for a left bound. I'm just going to enter 2 and enter, because that's left of where it crosses. A right bound, I'm going to do 3 and enter. Guess, I just put it anywhere near. Or you could plug in 2.7, whatever you think. There's the answer. So v of t equals 0 at t, not x, at t equal 2.707468. I'm going to store that. So I'm going to do second mode to get to my home screen. And I'm going to do X, the button next to the alpha button, store alpha A. So that number's stored for me in case I need it. So is the speed of the particle increasing or decreasing? Now, if you look at your graph, your velocity changes from positive to negative, right? I don't know if I just said that right, my brain. So v of t changes from positive to negative at that 2.707468. So therefore, the particle changes directions at this time. So I'm going to say the particle changes directions. Directions at t equal 2.707468 because the velocity changes from positive to negative at this point. Okay, that's it for A and B. The last two parts would be, well, actually wouldn't be on this year's test for you guys, but like I said, it could be on future tests, so I will finish this off. So we're doing part C. Yeah, I have a Zoom meeting. You saw that come up in about 12 minutes, so hopefully I can finish this before that comes up. So find the position of the particle times t equals 0. I can do that. So if you want the position at 0, it's going to be your starting position, which I know the position at 4, plus the change in position. Well, the change in position, I want to know how much it changes starting at 4, ending at 0, of v of t dt. I just punch all that in my calculator. X of 4 I know is 2, and then I do the integral. So if I do that, I get negative 3.815, done. And part D, the total distance traveled. So the total distance traveled from 0 to 3 would equal the integral from 0 to 3, absolute value of v of t dt. I punched at my calculator. I have 5.301. That was quick. That was easy. But let me explain why I use the absolute value real quickly here since I have some time before my meeting. Let's suppose the velocity looks like this. Can you suppose that with me? Oh, I know I have a meeting. Stop telling me. Suppose this area was 6 and this area was 2. And suppose this is A and this is B. Well, if I integrate from A to B, the net area would be 4. So if I integrate this velocity, we're supposing this is velocity, I would get an integral of 4. Well, what does this mean? It means I move 6 units to the right. This means I move 2 units left. Does that mean my total distance traveled was 4? No. I'd have to add these. So if I absolute value would make this positive, that would get total distance. What happens if I start and I move 6 right, 2 left, I end up 4 spaces from where I started. That's known as displacement or change of position. That's what you get when you integrate velocity, the change of position. But when you integrate the absolute value, you get total distance. That's what's going on. All right, that's it. I finished in time for my meeting.